Children, today we have to start the next chapter, chapter 2, inverse trigonometric functions. Last year we have studied trigonometric functions, its domain, range. So we have 6 trigonometric functions. So now we can write what is the domain and range of all these trigonometric functions. So first function is sin x. What is the domain of the sin x? Domain means set of all x values, then set of all y values, that is known as range of the function. So sin x domain is real numbers, set of real numbers. We can give any real number to this x. But the value of sine, that is in this interval, which interval? -1 to 1, closed interval. Sine value cannot be more than 1 or less than -1. It is in this range, -1 to 1. Then similarly cos function also, cos x, its domain is R. You can give any real number to this x, you will get a corresponding image. Then what is the range of cos function? That is -1 to 1. Then the next function is tan x. Tan x. Tan is defined as sin x by cos x. So it's a rational function. Sin x by cos x means it's a rational function. For rational function, the domain means this denominator part cannot be 0. So the domain is R minus, not R. We have to subtract those values at which this cos x is equal to 0. When this cos x is 0, cos x is 0 implies x is equal to 2n plus 1 pi by 2. This also last year we studied. 2n plus 1 pi by 2, that is multiples of 90, where n belongs to z. So these all values you have to subtract from R. So R minus set of all x such that x is equal to 2n plus 1 pi by 2. Then n is an integer. So this is the domain. What is the range of tan function? Tan function is set of real numbers, that is the range of tan function. Tan 90 is infinity, tan minus 90 is minus infinity. So its value is minus infinity to infinity, that is same as R. Now the next function, cot x. Cot x, we can define cot x as cos x by sin x. So the domain means R minus, which all values we have to subtract? The values at which the sin x is equal to 0. Sin x 0 implies x is equal to n pi, where n belongs to z. Sin x, sin 0 is 0, sin pi is 0, sin 2 pi is 0. So those values comes under this n pi. So these values we have to subtract from R. Set of all x such that x is equal to n pi, n is an integer. Then what is the range of cot function? That is similar to tan function. It is set of real numbers. Now the next one is cosec function. Okay, cosec x. Cosec x we can write as 1 by sin x. Okay. So domain means R minus set of all x such that the sin x cannot be 0. Sin x is equal to 0 implies x is equal to n pi. So R minus set of all x such that x is equal to n pi, where n belongs to z. 2. What is the range of cosec function? Cosec is 1 by sine. What is the range of sine function? Sine function's range is -1 to 1. Okay. So this -1 to 1, that numbers comes in this denominator. So its value is more than 1 and less than -1. So we won't get cosec value in between -1 to 1. So all real numbers minus, -1, 1. Or you can write its value is more than, greater than or equal to 1 or less than or equal to -1. Both sides, for when we draw the real number line, cosec value is 1 to more than that or minus 1 to less than that. In between those values it won't gives. So the domain is r minus set of all x such that x is equal to n pi and range is r minus minus 1 1. Or you can write like this, set of all y such that y is greater than or equal to 1 or y is less than or equal to minus 1, where y is a real number, that also you can write. Then the last function is sec x. Sec x is equal to 1 by cos x. Okay. So domain is r minus, what is the domain? R minus, this cos x is 0, that values we have to subtract. Cos x is equal to 0 means x is equal to 2n plus 1 pi by 2. X is equal to 2n plus 1 pi by 2, where n belongs to z. This is the domain of sec function. Then what is the range? It is similar to cosec function. Here 1 by cos x. Cos x range is minus 1 to 1. So 1 by that numbers is more than 1 or less than minus 1. Less than or equal and more than or equal to 1. So how we write? Range is equal to r minus minus 1 to 1. Okay. So look this. This you have to write in the notebook. Sine, cos, tan, cot, cosec, sec, all 6 trigonometric functions, domain and range. Domain in the left side, range in the right side. Then in this chapter, this already we discussed in the last year. This chapter we have to learn inverse trigonometric functions. So in the first chapter means relations and functions. There you studied a function is invertible. When we say that a function is invertible, if f is a function from a to b, then this f is invertible means there exists another function g from b to a such that FOG, F composition G and GOF, G composition F, both are equal to identity function. Or another way we can say that f is invertible means f must be on 1 and on 2, or another name for that is bijective. Then only we say that a function is invertible or inverse exists for that function. So here we have to discuss about the sine function. Is this function invertible? What is the domain and range of this function? R2 minus 1, 1. Is this function 1, 1? The first quadrant, second quadrant, third quadrant, fourth quadrant. What is the value of sine 30? 30 means pi by 6. Sine 30, sine pi by 6 is equal to 1 by 2. Okay. Then we know that sine, all functions are positive in the first quadrant. Sine is positive in the second quadrant also. So second quadrant, we know that sine theta is same as sine 180 minus theta. Okay. So sine pi by 6 is same as sine 180 means pi minus pi by 6, or sine 5 pi by 6. These are same. So is this function 1, 1? Also again after one rotation, that is this is 0 to 180, then up to here is 360. Then after one rotation again the same value repeats. We know that the range of the sine function is minus 1 to 180 is a subset of this R. So the values repeat. So is this function 1, 1? Definitely sine function is not 1, 1. Is it on 2? That we can say that it is on 2. On 2 means for every element in the second set there must be a pre-image. That is possible for every element in this minus 1 to 1. We can find a pre-image in R. So the function is on 2 but it is not 1, 1. So if we consider sin x from r to minus 1 to 1, the function is not invertible. Then what we do is, we divide the interval, that is we divide this domain into sub-intervals. So one interval is minus pi by 2, okay, or another interval pi by 2, 3 pi by 2, or minus 3 pi by 2, minus pi by 2. We can divide like this so many intervals. This r we divide into any sub-intervals. Now we check, is this function sin x from one of this interval to minus 1, 1. Is this function invertible? So what is sine minus 90? Sine minus pi by 2 is equal to minus 1. Sine pi by 2 is equal to 1. So we get these two values. Then in between, look, minus pi by 2. This is pi by 2 top. Here it is minus pi by 2. Minus 90 to 0, then 0 to 90. So this is the interval. We don't have this. Okay, this portion. Then here we have 0. What is sine 0? Sine 0 is equal to 0. So look, this interval we get minus 1, we get 1, then sine 0, 0 in between. Then in this quadrant sine value is negative. So we get minus 1 by 2, minus root 3 by 2, minus 1 by root 2, everything in this interval. And this first quadrant means sine value is positive. Here we have 0 to minus 1, that part is negative, 0 to 1 is positive side. See, so the values minus 1 to 1 and the domain minus pi by 2 to pi by 2. For every element in this, we can find a unique, distinct images, and also for every element in this set, we get a pre-image. So we can say that sine function from minus pi by 2 to minus 1 to 1, that function is 1, 1 and on 2. So we can define an inverse. Similarly, look this next interval, pi by 2, 3 pi by 2. So which is that interval? Pi by 2 is here. This value is 3 pi by 2 means it is 270. So this portion. Okay. There also, here in the second quadrant sine value positive and third quadrant sine value negative. And this here sine 90 means sine pi by 2 is equal to 1 and sine 3 pi by 2 is equal to minus 1. So we get these two extreme values. Then here at this point, what is that point? Sine pi 180, that value is 0. So look, we get minus 1, 1, 0. Then between, that is minus 1 to 0, that negative side we get from this quadrant, and 0 to 1, that is possible in the first quadrant. So again, sine function from which interval? Sin x from pi by 2 to 3 pi by 2 to minus 1, 1. That is also a 1, 1 on 2 function. So there also we get an inverse of this function. So like this we get so many sub-intervals. We can divide R into so many sub-intervals. Corresponding to each sub-interval we get a branch of sine inverse function. What is the notation? If f is a function, its inverse is denoted as f inverse. Similarly, the function is sin x, the inverse is sine inverse x. So corresponding to each sub-interval, we get a branch of function sine inverse x. But we say that the branch with the range with the branch minus pi by 2 to pi by 2. This is known as principal branch. Okay, understood children? Corresponding to every subinterval, corresponding to each subinterval, we get a branch of sine inverse, and the range with this branch is known as principal branch. So sine inverse we defined as, all other intervals you can neglect, there also exists sine inverse function, but this we call as principal branch. So sine inverse, look, sine function from minus pi by 2 to minus 1, 1. This function is 1, 1 and onto. Hence, an inverse exists for sine x. That inverse is denoted as sine inverse x, and it is from the second set, that is minus 1, 1 to minus pi by 2, pi by 2. So this you have to learn, sine inverse x. What is the domain of sine inverse x? Minus pi by 2 to pi. Domain of sine inverse x is minus 1 to 1 and range is minus pi by 2 to pi by 2. Now, if y equal to sine inverse x, then x is equal to sine y. It's also last year we studied f inverse or f of x is equal to y, then x is equal to f inverse y, the notation. So if y equal to sine inverse x, then x is equal to, apply sine on both sides. So we get x is equal to sine y. Then sine of sine inverse x. Look here, sine of sine inverse x is equal to x. Then look here, x, sine inverse x. Sine inverse x, what is the domain? Minus 1 to 1. So x must be in that interval. Okay, so this you have to learn. Sine of sine inverse x is equal to x if minus 1 less than or equal to x less than or equal to 1. Now the same way, sine inverse of sine x is equal to x. When, look, this is sine x, x is associated to sine. Here x is associated to sine inverse. So here what is the domain of sine function? Sine function domain is minus pi by 2, it's less than or equal, minus pi by 2 less than or equal to x less than or equal to pi by 2. Here we didn't take domain as R. Here sine inverse is defined only from minus 1, 1 to minus pi by 2, pi by 2. So when we consider this sine x, so you have to take this domain. Okay. So x is minus pi by 2 less than or equal to x less than or equal to pi by 2. So this also you have to learn. Understood children? So once again, first we discussed domain and range of all 6 trigonometric functions that you have to write in the notebook. Then after that, we discuss when the sine function is invertible. When sine function is from R to minus 1, 1, then the function is not 1, 1. So inverse does not exist for this sine function. So we divide R into many subintervals. There are a lot of subintervals like this, and when we consider domain as these intervals, the function is 1, 1 and onto. So corresponding to each subinterval, we get a branch of sine inverse function. But the range with which branch? Minus pi by 2 to pi by 2, that is known as principal branch. So sine x is defined from minus pi by 2, pi by 2 to minus 1, that is 1, 1 and onto. So we can define an inverse from minus 1, 1. Okay. Sine inverse from minus 1, 1 to minus pi by 2, pi by 2. Then you have to learn this also. Y equal to sine inverse x means x is equal to sine y. And these two result also. Sine of sine inverse x is equal to x if minus 1 less than or equal to x less than or equal to 1, and sine inverse of sine x is equal to x if minus pi by 2 less than or equal to x less than or equal to pi by 2. Okay children.